Hello and welcome to another video. In this video, we will look at the time response of a first order system. Suppose this is the transfer function a by s plus a, and you are giving a step input to the system. What is the response? How to analyze the response of the output? So that is what we are seeing this. How can we quantify? How can we tell the significance of different parameters of this output? Like rise time, settling time. See those terms in detail. How to quantify this response? So based on the parameters of the system, it has some relation with the kind of output that we are getting. So we will quantify how to represent that output. Suppose you have a system with a transfer function a by s plus a, and you are giving a step input. The Laplace of the step input is 1 by s, unit step input. Now, when you are applying that to the system, this R of s is the input and G of s is a transfer function. So G of s is a by s plus a, that is given, and you are giving a unit step input. So to get the output, we will multiply R of s and G of s. Since G of s is the ratio of the Laplace of the output divided by the Laplace of the input. So taking this Laplace of the input to this side, we will get the Laplace of the output. Now, this can be decomposed by partial fraction expansion. By partial fraction expansion, after calculation, we will get the value of k1 as 1 and the value of k2 as minus 1. Now, we will calculate the inverse Laplace. After partial fraction expansion, we got the value as 1 by s minus 1 by s plus a. Now the inverse Laplace, after taking inverse, we can take get the time domain. So the Laplace of 1 by s is 1 and the inverse Laplace of 1 by s plus a is e raised to minus 80. So this is the output response C of t for a unit step input. Now, as we have seen in the previous video, this part is the forced response and this part is the natural response. This part is called forced because it is due to the input, and this is due to the system characteristics, systems, poles and zeros. Now this is the output response of the system. The C of t, when we plot, it will be something like this. So for a step input, say, so the green line shows the input. So for a step input, the output will be shown in the red line. So it rises like this. So there are some significance of this curve. So the significance of the parameter A. So 1 by A is called the constant of the response. So this is some system characteristics. So it depends on this parameter A. So it will be different for 1 by S plus 1. It will be different for 5 by S plus 5. So it depends on the parameter A. So if the value of A is 1, the response will be different from the response when the value is 5. So this 1 by A is called the time constant of the system. The definition of this time constant is that it is the time for e raised to minus 80 to decay to 30% of its initial value. So this value, this blue line shows 1 by A, the time taken for the system to reach this point. So how did we get that? So e raised to minus 80, when you substitute the value of t equal to 1 by A. So the value of the time, value of the response when time t equal to 1 by A. So at time t equal to 1 by A, this e raised to, when you substitute it in e raised to minus 80, you will get e raised to minus 1, that is nothing but 0.37. So time for e raised to minus 80, the time for e raised to minus 80 to decay to 37% of its initial value. The first definition of time constant is that e raised to minus 80, the time for e raised to minus 80 to decay to 37% of its initial value. So the time taken for e raised to minus 80 to decay to 37% of its initial value. The first definition of time constant is that the time for e raised to minus 80 to decay to 37% of its initial value. So e raised to minus 80, the time taken t equal to 1 by a. So the time taken for e raised to minus 80 to decay to 37% of its initial value. Another definition of time constant is that time constant is the time taken for the step response to rise to 63% of its final value. So the final value is 1, and the time taken for the response, this is the response, to rise to 63% of the final value. Final value is 1, so 0.63 is the value at what time that 0.63 is reached. So that is a time constant. So that is got by, earlier we have seen the C of t. Earlier we have seen that C of t equal to 1 minus e raised to minus at. So at t equal to 1 by a, we will get 1 minus e raised to minus 1, that is 0.63. So that is 63% of the final value. So time constant can be considered as the transient response specification. So when a step input is given to the system, so in the blue line, when a step input is given to the system, the output response is the red line. So it is the transient response. Time constant can be considered as the transient response specification for the first order system, since it relates the speed at which the system responds to the step input. Now, another specification of response is rise time. Rise time is the time for the waveform to go from 0.1 to 0.9 of the final value. So the output, so this is the rise time, PR. So the time taken to reach 10%, this is the 10% of the final value, and to 90% of the final value. So this is the 90% of the final value. So this duration is called rise time. So the time taken for the response to rise from 10% to the 90% of the final value. So the rise time is calculated by, so the response value at 90% and the response value at 0.1%. So we will subtract both. So the rise time is got by 2.31a, that is the 90% value, and 0.11 divided by a. So the difference between 2.31a minus 0.11a is 2.2a. So 2.2 divided by the rise time, the time taken for the response to rise from 10% of the final value to 90% of the final value. The next parameter, next specification is settling time, TS. It is defined as the time for the response to reach and stay within 2% of its final value. So the time taken, so the entire time starting from 0, time taken and to reach 90 within 2% of the final value. So this is 2% of the final value. The time taken for the response reach and stay within 2% of its final value. So that is called settling time. So 2% settling time can be two types. 2% settling time is, so 2% of the final value. So we will substitute C of t equal to 0.98 and solve for t. We will get TS is equal to 4 by A. Similarly, there are various other criteria. So 5% settling time. So there can be any other criteria. So 2% settling time value is given by, so 2% settling time value is given by TS equal to 4 by A. So these all parameters depend on A. So A is the deciding factor for a first order system. So the value of A determines the settling time. It also determines the rise time. And it also determines the time constant. So these are the different parameters, different specifications for a first order system. Thank you.